Well, hey there, it's your old pal, Mr. Cook, and we're going to continue with this review. We just got through the first page. Now let's do the second page. So it says if the x coordinate is positive and the y coordinate is negative, what is the sign of the tangent at that point? So yeah, if like, we have our coordinates, right? Remember x and y. This is going to be the same thing as the cosine and the sine of the angle. Okay, so if the x coordinate is positive, that means that the cosine is going to be positive as well. If the y value is negative, that means that the sine is going to be negative. And then if they want to know what the sign of the tangent is going to be, all you have to do is just remember that the tangent of some angle is going to be equal to the sine of the angle over the cosine of the angle. That's what we call the quotient, one of the quotient identities. And that if you didn't know that, if you didn't know where to start, that's going to be one of your identities over here. Where the heck is it? I guess that's just one of the ones you got to memorize. Okay. Yeah, same thing with like 1 over sine is equal to cosecant and all that stuff. You just got to memorize those ones. Oh wait, did they have it on the unit circle? No, sometimes they do have it on there. Oh, they do have it. There we go. So tangent is equal to the sine value over the cosine value, y over x. So there you go. If you didn't have that memorized, you can always look around your unit circle. There'll be some information. Anyways, so tangent is sine over cosine, and if sine is negative, that means that we have a negative over a positive, which is going to be a negative overall. So tangent is going to be negative for this one. All right, next up, number 8, the following function, y equals 5 cosine of x minus c plus d is graphed below. Determine the vertical shift, the phase shift, and also the period for this thing. Okay, let's see here. Well, it looks like the peak value is happening at 0 here for our cosine. It looks like we kind of have to guess a little bit on some of this. Let's see here. So 10, 11, 12, 13. So that's a height of 13. And then the lowest point is 1, 2, 3 right there. Okay, so let's see here. We got to go halfway in between to find the, like where it's been elevated to. So halfway between 3 and 15, or 3 and 13, sorry. Let's see what that's going to be. So 3 plus 13 is 16. 16 over 2 is 8. So at 8, that's where our center line is. All right. And then let's see. The amplitude says that it's going up by 5. And let's make sure that's true. 1, 2, 3, 4, 5. Yep. 1, 2, 3, 4, 5. Yep. Okay, there's our amplitude. Okay. So determine the vertical shift. The vertical shift is going to be that value right there, 8, the center line. So that value D is going to be 8. Excuse me, and that's the vertical shift. And remember that like the vertical shift is where this like little center line right here gets moved to, okay? For your cosine or your sine or whatever. All right, now for the phase shift. Well, if this is cosine, this already is the cosine graph. It looks like it goes perfectly from 0 to 2 pi. So that means that it doesn't shift to the left or the right. So the phase shift is 0. So C is 0. And I know that because like typically a cosine graph will start at the maximum, which is what it does like on this one at 0. And then it goes down and then it goes back up like that, And that'll happen from the span of 0 on the x-axis to 2 pi or 360 degrees on the x-axis. And that's like exactly what happens here, going from 0 to 2 pi. So there is no phase shift. So C is equal to 0. No phase shift. And then the last thing is find the period. Since there's no multiplier on the x value, that's also going to be a standard period for the cosine function, which is going to be 2 pi. So the period, and remember that the period is like, how long it takes to go from like peak to peak, like that length on the x-axis. And that goes from 0 all the way over to 2 pi. So 2 pi is going to be the period for this one. Okay, so those are all 3 of those ones. It's just basically like looking up at the transformations that happen with the function. What's the phase shift in radians of the given functions below? So there are a couple different ways to find the phase shift. I always do it the same way. And I don't know if a lot of teachers do it the same way, but like what I do is I take the, whatever the equation is inside the parentheses, And what I do is I just set it up as an inequality. So theta over 2 plus pi over 2. And I say that it's between two numbers, 0 and 2 pi. And what I do is I then isolate this guy, solve for theta or x or whatever my unknown value is. So the first thing I do is subtract pi halves from both sides. So I subtract pi halves from here, pi halves from the middle. So I just have theta over 2. And then I subtract pi halves from 2 pi. So 2 minus a half is 3 halves. So it's going to be 3 pi over 2. And then the last thing is I get theta all by itself. So I multiply all the sides by 2. So I get negative pi over, negative pi is less than theta, which is less than 3 pi. All right, so this helps me to find my phase shift. So since it started at 0 and then it goes over to negative pi, so that's like going like this, okay, like on your graph, starting at 0 and then going over this way to negative pi. The shift has started off like, it's supposed to start at 0, but if it went to negative pi, that means that it shifted to the left by pi radians. So left shift by pi radians. So there's, that's the answer for that one. And then I do the same thing for the other one. So I take the stuff that's inside the parentheses, 2 theta plus 2 pi. And I do the same thing. I set it, less than or greater than 0, less than 2 pi. And then I solve. So I subtract 2 pi from both sides. So that gives me a negative 2 pi over here, less than 2 theta. And then, and then less than, let's see, 2 pi minus 2 pi is 0. And then I divide both sides by 2, and I get negative pi. Negative pi is less than theta, which is less than 0. Okay, so that means that, again, it looks like it has gone from 0 over to negative pi. So that means it's another shift to the left by pi radians. There we go. So that's all you have to do for number 9. There's phase shift. Number 10, the monthly average temperature, Y, in degrees Fahrenheit for a city where X is the month, is given by that function. Note that when X equal to 1, that's January, X equal to 12 is December. So what is the minimum average temperature and what is the maximum average temperature? So if temperature is the output, the Y value, degrees Fahrenheit temperature, then that means that, if you graph this out, a sine function usually looks like this. Starts at 0, goes up and down like that. What they're looking for is like the top peak and the bottom peak from that. And here's how you can find that. What you do is you find like this like center line right over here, which would be like your vertical shift, so 45. And then it goes up and down by the amplitude. So if I went up by 30 from there, what would that be? So if I took 45 and added on 30, that'd be 75. So 75 degrees is going to be the biggest possible value, the maximum. And then if I went down by 30 from 45, that would be 15 degrees. So that's going to be the smallest value, 15 degrees. So what is the minimum average temperature? That'd be 15 degrees. And then that upper value, 75 degrees, is going to be the maximum temperature. And, that's how you'd answer it. And I bet they'd probably have like a, combination of those two values for the multiple choice question. So, just figure it out. And I guess, like what about the phase shift ones? How can you do those ones really easily? You could probably just graph the sine function, like regular old sine, and then graph the equation y equals 4 sine of theta over 2 or x over 2 plus pi over 2. And you just see that it gets like moved over to the left by some amount. And then you could probably infer that it's just pi. There's a couple different ways to do that. What is the period in radians for the given function? Again, if this is a period, I'm going to handle it the same way that I did the previous problem, because like doing it this way actually also tells you the period, because the period is just going to be how far, like the distance between this lower value and this upper value. So how far away is negative pi from 3 pi? That would be a total distance of 4 pi. So 4 pi would be like my period for number 9, the first part of number 9. So for number 11, I would do the exact same thing. I would just take 3 theta plus pi, and I'd say that it's greater than 0 and then less than 2 pi. And then what I would do is I would get theta by itself and see how far away the x value or the lower value is from the upper value. So all right, let's go ahead and solve it out. So if we subtract pi from both sides, we get negative pi is less than 3 theta, which is less than, and if I subtract pi from that, just pi. And then, I divide by 3, so I get a negative pi over 3 less than theta, which is less than pi over 3. And, if I just find out how far away those two are from each other. So how far away is negative pi thirds to 2 pi, to pi thirds? And that's going to be a total distance of 2 pi over 3. And that would be my period. Okay, similarly, I bet one of these is supposed to be a theta. Let's call that one theta right over there. So theta over 3 plus pi over 2. Okay, so we got to go between 0 and 2 pi. So if I subtract pi halves from both sides, I get a negative pi halves on this side. And then 2 pi minus pi halves, that's going to be 3 pi halves. And then if I multiply both sides by 3, I get the following. I get negative 3 pi over 2. And then if I multiply by 3, I get a 9 pi over 2. Okay, and then how far away is negative 3 pi over 2 to 9 pi over 2? Well, that's going to be like, let's see, 3 on the left and then 9 on the right. So that's going to be a total of 12 pi over 2, which is going to be 6 pi. So that means that my period is going to be 6 pi as a length. Okay, so there you go. That's number 11. And we're also done with another page. So that'll be the end of this video. And so if you have any questions, make sure you ask your teacher. I hope this is helpful. I'll make another video for the next page and I'll see you then. All right. So I'll see you later. Bye-bye.